We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, students. I am Dr. Chintan Jotaniya, Assistant Professor of Physics, SHANKERSINH VAGHELA BAPU Institute of Technology. We will discuss about module number 4 of Physics, Superconductivity. This unit is extremely important as a exam point of view because it is easy and it contains examples and some theories which are important. So we will take a look which are the topics we will learn in this superconductivity module. So let us see one by one. So the topics, the contents which we are covering in these modules is first is the introduction of superconductivity. Basic introduction of superconductivity we will learn in this point. Then comes the discovery, how superconductivity has been discovered. Then comes important properties of superconductors. Then its extremely important property of Meissner effect. How many types of superconductors we are having? BCS theory, penetration depth, Josephson junction. And lastly, the applications of superconductors that we will learn. It's all, this module is also include examples which are easy to solve. So this is one of the most important and easy unit or easy module of the physics which you can easily understand and score marks in the exam. So exam point of view, this is one of the easy and good unit to prepare. So let's go one by one. The first we will go for introduction part, how superconductivity has been discovered and that we will learn. So first we are going for the superconductivity introduction, and for that we will have the introduction part, how superconductivity has been discovered. But before that, you should know what actually superconductivity is. We know that the types of materials which we are having right now, basically they are classified in 3 groups. Some of them are conductors, some of them are insulators, and in between we are having an intermediate state, and that is called as a semiconductors. So conductors, semiconductors, and insulators we are having. Conductors, they are having high conductivity, low resistivity, while when we go for insulators, they are having extremely high resistivity and very poor conductivity. So one step ahead of conductor, of course they are having high conductivity even if they show some resistance. So that is the reason they are having some amount of resistance whenever the current is flowing. Most of the metals, they are the examples of the conductor. So in short, they are having some resistance which is present. But now we are going one more group of the materials which shows extremely negligible resistance, and that group of materials are called as a superconductors. And what is actually this superconductivity is? So superconductors and superconductivity. So superconductivity is nothing but it is a one type of phenomenon of exactly zero electrical resistance and complete expulsion of all the magnetic fields when it has been cooled below its characteristics or critical temperature. So that is, we can say, when some materials, most probably conductors, when they have some resistance, so that resistance is because of the movement of the ions, and when they are collide each other, they are having some resistance. So we are going to fix the movement of these atoms or ions. So once they are not vibrating too much, they are showing extremely negligible resistance. So that we are doing in the case of the superconductors. We take a material, we lower the temperature, lowering, we lower the temperature up to its critical temperature, at which the atoms, they are almost fixed. They are not vibrating from its mean position too much. So whenever the electrons it is flowing, it doesn't offer any kind of a collision with either ions. So they are showing the extremely high amount of current which is flowing, and that is the phenomenon of superconductivity. So superconductivity is nothing but it is a one type of phenomenon in which we are having exactly zero electrical resistance, almost zero, not completely zero, almost zero. In superconducting state, magnetic field lines are completely expelled by the material. So we can write this thing, but this can happen only at some critical temperature. It varies from material to material. So this is the way we can define the superconductivity, or another way also we can define superconductivity is a phenomenon in which certain metals, alloys, and ceramics conduct electricity without resistance. But this is can be happen only when it has been cooled below a critical temperature. Then this is the observation thing. So superconductivity, you can define either of these. First or second way you can write about superconductivity. And the material which shows these properties, they are called as a superconductors. Superconductors are the material, and property of these material of showing exactly zero resistance, that is called as a superconductivity. Which materials shows the superconducting state? So first superconducting material which was found, that was the mercury. So mercury, zinc, vanadium, tin, niobium. These are the few examples of superconducting materials. So you can also remember the name of these materials: mercury, zinc, vanadium, tin, niobium. These are the materials which shows superconducting behavior. So this slide, you have two questions and answer. What do you mean by a superconductivity, and define or state the materials which shows superconducting nature. So examples of superconductor you should remember, and this is the either or definition you can write. So that is the important thing. So superconductivity, this is the thing. Who have discovered, or the elements which shows the superconducting nature. So I have introduced a periodic table here. Sometimes the show superconductivity at some ambient pressure also is needed. So blue color, that is at ambient pressure, and sometimes the green color elements which is showing here, they shows the superconducting nature only under the high pressure. So this is for your reference only. Who have discovered the superconductivity? So when we look at the discovery of superconductivity, the name Ike Kamerlingen owns, the Dutch physicist who have discovered first in 1911 about the superconductivity. So the inventor of superconductivity is Ike Kamerlingen Onnes. in 1911. So this is his picture. He was experimenting in his laboratory with metal which is called as a mercury wire, and then he has observed a extremely extraordinary property shown by mercury. So that we will discuss, but this is the actual real picture of its laboratory. So the inventor of the superconductivity is Haig Kamerlingh in 1911. He has discovered about the superconductivity. What he was doing, he was experimenting with a metal wire, and another metal wire is the mercury metal wire. So when Owens passed the current with mercury and he measured the resistance by changing the temperature, he has noted that normal conductor, which is just I have highlighted here, non-superconducting material, when he reduced the temperature, even if at 0 Kelvin, this normal metal wire is having certain resistance which is present. So even if at 0 Kelvin, these metals wires they shows some amount of resistance to be present. So same experiment when he was performing with mercury wire, he has found some extraordinary thing. When he was lowering the temperature and lower the temperature again and again, and when he reached about 4.2 K, 4.2 Kelvin, he observed that a sudden change in the resistance has been offered. So at 4.2 Kelvin, the mercury shows sudden drop in the resistance and it becomes 0. So at 4.2 Kelvin, the mercury shows extremely fall in the resistance and it becomes almost 0. So what is actually this thing is? So this is the extraordinary behavior shown by the mercury. So he was thinking that this is somewhat extraordinary properties of mercury have, and he have given this temperature at which the material resistance is suddenly falls to 0. He gave the name critical temperature, TC. So TC stands for critical temperature. So the material which shows these kind of the behavior almost 0 resistance, he gave the name that material as superconductor. So first superconductor was found by the Kamerlingh when he was experimenting with mercury. So mercury shows superconducting nature at exactly 4.2 Kelvin. So this is the graph which he he was plotted, and we can see here at 4.2 Kelvin its resistance is almost 0, 10 to power minus 5 ohm. Almost negligible resistance is offered, while when other metals they are having high amount of the resistance even if at 0 Kelvin. So we have one more concept here. What do you mean by a critical temperature? So critical temperature is nothing but the temperature at which material resistance suddenly falls to 0. So that temperature is called as a critical temperature. Of course, it is varying from material to material. Here, mercury shows the critical temperature about 4.2 Kelvin. So when we change the material, its critical temperature is also going to be changed. So that is the important first discovery of the superconducting element, that was the mercury, and the critical temperature of the mercury is 4.2 K. So doing that thing we can see here. So in 1933 again the discovery is going on. So after his discovery of superconductors, the discovery is going on in the field. And in 1933, Walter Meissner discovered the superconducting material that they are repelling all the magnetic field lines. And this phenomenon is called as the Meissner effect based on his name. So he observed this phenomenon and he gave this phenomenon as Meissner effect. So what is actually Meissner effect is? So we will discuss later on. But Meissner effect is nothing but at certain critical temperature, material becomes superconducting and they are expelling all the magnetic field lines. So this phenomenon was observed by Walter Meissner. So that was the important discovery in the field of superconductivity we are having. Again, 1957, three group of scientists, they John Bardeen, Leon Cooper, and John Seriffer gave the theory of superconductivity, which is commonly known as the BCS theory. So these we will learn deeply later on, and they got also the Nobel Prize. Meissner also got the Nobel Prize. Holmes also got the Nobel Prize. So these group of scientists, BCS. So based on first letter, Bardeen, Cooper, and Schrieffer, this theory has given the name BCS theory. We have detailed question about BCS theory. So we will discuss more about BCS theory later on. So they also got the Nobel Prize. BCS theory will explain the superconductivity at the temperature close to absolute zero for the elements, and they are some alloys also. Then again 1962, Josephson, he has also observed the tunneling effect in the superconductor and he gave this theory as a Josephson effect, and we will have also its application as a SQUID, superconducting quantum interference device. This is also we are having one point in syllabus, so that also we will discuss. But that was some discovery by Josephson effect, and its application we are having SQUID. Lot of invention are still going on in this field of the superconductivity, but these things, superconductivity, which we are having or which we observe, that is at extremely lower temperature. So that is the drawback we can also say. So if we want a superconductor, we have to lower the temperature too much. So we are not having right now any superconductor at room temperature. So that is a field of research. So we can have a superconductor at room temperature, but right now it is not. So the research is going in the field of high temperature superconductors. Scientists are all working on designing of superconductors that can operate at room temperature. So if we found a material who can have the superconducting nature at room temperature, it changes the all world. What we are using conductors right now everywhere, they have some resistance. We lose the energy as a form of a heat or some another energy. But by replacing that conductor by superconductor, we have extremely negligible resistance. So extremely high efficiency we can obtain by using superconductors. So that is the importance of superconductors. So few I have highlighted, few Nobel Prize in the field of superconductivity which was given. First Nobel Prize was given to Heike Malling-Onnes, of course, the father of this superconductivity, for the investigation on the properties of matter at low temperature, and also he have liquefied the helium. So he got the Nobel Prize in 1913. Then three group of scientists, John Bardeen, Leon Cooper, and Robert Seriffer in 1972 for their theory of superconductivity. They are jointly got the Nobel Prize, that is called as a BCS theory. Then Josephson and its co-scientist in 1973, got the Nobel Prize by giving the concept of tunneling effect in the superconductors, and they are called as a Josephson effect. So later on in 1987, Muller and its co-scientist George Bendros, he also got the Nobel Prize in the discovery of superconductivity in ceramic materials. So a lot of research is still going on. In 2003, this group of scientists, they are also getting the Nobel Prize for their pioneering contributions in the field of superconductors and superfluids. So these is few Nobel Prize history in the field of superconductivity we are having. So research in this field is going on, and we are trying to get the material who have superconducting nature at somewhat higher temperature. We are trying to reach up to the room temperature. If we obtain the material who becomes superconductor at room temperature, it changes the world. So that is the few introductory part of superconductivity we are having. So in next video, we will learn about the what are the important properties of superconductor we are having. Thank you.